Okay, so just a couple things to review as we go through these mechanisms, right? These kind of reactions with ketones and aldehydes. Again, there's two basic types, acidic conditions and basic conditions. In acidic conditions, you'll see an H plus or HCl or H2SO4 or HBr or HI. And the first step is always protonation. You protonate the oxygen of the carbonyl to make the carbon of the carbonyl more reactive, more electrophilic. The other type of conditions are basic conditions. And here's two examples of those. Reduction of alcohols, and of course there should be a minus charge on that boron. And Grignards, right? H minus and C minus. These are both basic conditions. In the first step in a basic condition reaction, what's the first step? Addition. Addition, right? You make a tetrahedral intermediate. You ask yourself, do I have any good leaving groups? And if you do, you let them leave. And you keep adding things. If you don't, you go to the next step, which is protonation, right? So in basic conditions, addition, then protonation, right? Addition, tetrahedral intermediate, no good leaving groups, protonation, alcohol. Grignard, negatively charged carbon, addition, tetrahedral intermediate, no good leaving groups, protonation, alcohol, right? And you can see the different ones you make. Okay, so that's review to remember those kind of things. Now there's more. Let's see what else we have in store here. We could also do a hydration, right? Which is just exactly what it sounds like. Hydration meaning you're adding what? Water, right? And you can do this in acidic or basic conditions. So in the first step, let's try it with basic conditions. I think I drew this out before. So basic conditions would be OH minus and water. So let's take a couple minutes and see if we can do that on our own. All right, let's take a look at this. One thing, OH minus, the hydroxide, is a catalyst. It's got to regenerate it before we're done. So the first step in this base catalyzed mechanism, of course, since we're in basic conditions, addition. Going to give us a tetrahedral intermediate. Tetrahedral intermediate, we ask ourselves, do we have any good leaving groups? We do not. I mean, we could have the OH leave again, but that would just be going back to where we started. So then we got to go looking for something to be deprotonated, right? And just that water floating around is just the ticket. That, and that'll get us here. And it'll also regenerate the OH minus as a catalyst. So same set of starting materials, not quite the same. Same starting ketone. But now we're going to use H plus as a catalyst in water. We're going to get to the same exact gem diol, which is a fancy way of saying an alcohol, two OHs on the same carbon. Can we do the mechanism for this one? Let's try that. So we just did basic conditions. Now let's talk about acidic conditions. First step in basic and acidic conditions is going to be protonation. Why? Because H plus is the best electrophile we got. It's got no electrons. It's plus charge, right? So we're going to protonate. So the first step is a protonation. Why do we do that? Right, that makes the carbon of the carbonyl that much more electrophilic, right? Makes it that much more reactive. Even though there's a plus charge on the oxygen, that's not really where it's electron deficient at. It's electron deficient at this carbon or that hydrogen. So it makes this carbon more reactive. The only other thing in the reaction mixture is water. So water can add in now. Do that nucleophilic addition. Form a tetrahedral intermediate. We balance our charge in acidic conditions. You better have a plus charge, no minus charges floating around here, right? Make sure we have the right charges floating around. At this point, somebody's going to say, "Oh, wait, I want to do." Well, what do you want to do? Nothing. You don't need to do anything. You need to remember, I need to remake H plus because that's my catalyst. How can I do that? You could use water if you want to, or right? Hydrogen can just fall off. Bye. So that hydrogen fell off, right? It gave up the 2 electrons, right? Because H plus has no electrons. So then you get, in acidic conditions, you get that diol, that gem diol.